Let's solve another problem from LeetCode. It's LRU Cache. So first try to understand and then we'll write the code here. So LRU Cache is a list recently used cache. So you see that how it works based on the example. Like uh, let's say here, and in this problem, I'm just going to use doubly linked list, and using with this, we'll understand the problem. Also, we'll solve the problem. So in this example, we have given 2. So that means the size of that cache is 2. The size of cache is 2. And now we'll put this key value in a cache. So 1, 1. So if I put the 1 in a doubly linked list, I'll put that in a front. So front, there will be 1. And again, there is another value, 2, 2. So I'm just writing here just one key, but actually we'll put the note where we'll put 1 and 1, both key and value. But just here, just for simplicity, I'm just putting the key here. So anyway, I put the key 1 here, and when the second value comes 2, I'll put this 2 in the front. So this is a front. So here I'll put the 2. Okay, so that's good. 2, and the size, the size of this doubly linked list or this cache is 2. So I put the 2 there, and next time I want to get the value for 1. So of course I get the value for 1, and for the 1 I know the value each 1 for the key. I'll get the 1. So as soon as I get the 1, this value we recently we used. So that's why I'll put this 1 in the front, and the 2 will be here. So because the 1 recently used. So next time I'm going to put 3, 3. So when I put the 3, okay, I'll put the 3 in the beginning, 3 here. In the front, I put the 3 in the front, but the size of this cache is 2, so it's a one more item. So when we evict the item from this cache, then we'll use like the least recently used. So these are the most like we mostly are using this, but this is the list value that's recently used 2, and that is in a backside. So I will just remove this 2. Okay, so next time when I get the value for 2, then the 2 is not available, then we'll get uh, like -1 for this 2. So in this way again, if I put the 4 here, so okay, 4 will go in a front again, and it's more than 2 length of this cache is more than 2, then we'll remove from back. So this is a 4, 3. And next time when you try to get the value of 1, the 1 doesn't exist here, so we'll not get the value of that. So that's the LRU cache, and let's implement this using doubly linked list. So yeah, I'm using the doubly linked list because it's very uh, fast, to put that node in a front, or remove it from the back. So that's why both way pointer is in both way. So it's a faster. So that's why I use the doubly linked list. Okay, so here in the Golang we have a list, and using the list we can use the doubly linked list. So let me import this container.list, and there are many other problems I have explained using the container list. There's a stack problem or the queue problems. You can go and check that video, and you can get better understanding how to use this list. So I use this list library for the queue and for the stack, and this time I'm using in this exactly same way, but I'm use a different function and to make it doubly linked list, or to explore the doubly linked list functionality. But it's a doubly linked list. Okay, so in a LRU cache, and here we'll in this first we'll create the constructor, and then we'll get some value, and then again we'll, if you get some value, some key put and try to get the value, we'll get the -1 here, and then we'll call the function put, then it will store the value there. Okay, so the first of all I need LRU cache here, so I'll define a variable capacity, and that's a int, and then I need a cache, so this is the map, so map of int, and then I'll say the list element. So here in a map, I will store key, and when I want to store the value, so the value will be uh, I'll put that key value together here. So I want to store the key value together. So for that, I need another struct, let's say data, and it's a struct, and then I can say it's a key int and value also int. So I want to store key key here, and then in the value I want to store key value both. So key value both. So eventually, like if I think, I could do this, like I can define this data type here. So that's where, the key is whatever the key we passed, and the value will be this data. We could have done this, but uh, that's not going to solve the problem, because in the list used a doubly linked list, and it has functionality like push back or push in front or move to front or move to back, and all that functionality returns element. So if you want to adjust somewhere, we say that okay, I want to move the element to the front, so I want to get exact element, and in a map we have the exact element, then uh, we can get that element and we can move uh, in a front or in a back side, or we can remove. So that's why what I do that uh, in this element I will store the data. So the element can take any type. So this is just a wrapper. Inside that I will store my data. So we're also thinking why I'm storing key value both. We can store just a value here. So, but the problem is if you store the value, the next time in a cache, like if you try to put the value key value pair, and that already exists. So if that already exists, then in that case we want to get the key in order to delete that. So if the value exists, that exists in a front, so in a front or in a or in the like backside. So wherever it exists, you want to delete, you want to get the key. And in that case, we'll have only the current key in a put. So whatever we want to store, but if you want to move some element from the front or back or from the middle to here and there, in that case, we need a key. So that's why I want to store a key also. So it will be easier. So we'll understand that first I'm saying there. But anyway, so LRU cache, there is a capacity, there is a cache, and in a cache, I'm going to store the key, and this is the wrapper. Inside this, I will put my data here. Another variable I will put here, that's a DL. It's a doubly linked list. And in a doubly linked list, it's a list star list list. So that's the doubly linked list. Or if you see another example uh, for the stack and the queue, I have explained where I create, the stack or list or stack or queue using this function list function or list. Yeah, so this type, not a function, this type. Okay, so we'll have LRU cache ready now in a constructor. First we call the constructor, so that's why we want to initialize this, and in a constructor we want to say what is the capacity of this DL. So that's why here let's return and this LRU cache. me copy this. And capacity will be whatever the capacity we pass. So that's a capacity. And then cache. So the cache, we just initialize the cache. So it's a make map, key is a type, and the value will be list dot element cache and then DL. So the way to initialize this DL is we just say list dot new. So in this way, doubly linked list that's got created. So next thing is, when the key value comes, we need to put the key value here. So we got this key value. I want to put that in a data. So let's create one variable or object for this data, and key, here we need a comma, key comma, and then value is equal to value. So we have, so new data comes, and when the new data comes, then there's a data, and we want to store that in a doubly linked list and also in a cache. So let's store first in a doubly linked list. So this is, if I use this object, this, then I will be able to call this DL, because this object is type of LRU cache, and a LRU cache we have defined here. So this dot DL, so it's this dot DL dot dynamic link, doubly linked list. So here in a doubly linked list, this dot DL is equal to, so we want to store this thing here. So we'll just say there is a function for this as a push front, and push front will pass this data here, and this is going to return the element. So this element has this data, and this element we will store in a map. So we have this cache is a map where key will be this key, and then value will be element. So okay, so this is good. So we stored this successfully. Next time, like let's say when we get same key, then what will you do? The same key. When you get the same key, then in that case, a key already exists. You just move to front. So that's when we update the value if there is anything new. So let's say here I can say element dot okay, and I can check in a this cache, just put the key here, and it will return an element because you stored the element there. So if that already exists, return the element. And in this case, what we do, that element, we update the value element dot. So this time again we'll create the data. So in a data and a key value, we'll put it there because that anyway that's already exists there. So if the value is the new, we'll want to put the new value. So it's a data and key is equal to key value. So we'll put that, and then we'll update the element because whatever element we got from the cache. So element dot, and then value, and it will element at value is this data. And also we updated this, and we let's move this element in a front, because we just now we access this because this exists and we access, so that's why move that in a front. So for that in front of the DL or doubly linked list DL, and then you can just call the function move to front, and we'll say that element. And here thus we're done for this, and then the return. One last thing here, we can say if this is full, LRU cache is full, so we can check that if this DL dot length greater than capacity, then we want to remove uh, the element from the back side. So we'll use the DL, and so we can just say evicted, and from the this capacity is this dot capacity, so this dot DL, and then from the back, so you can just say there is a function called back. So we want to remove this one evicted. Okay, so we got this, and we'll use the function this dot dl doubly linked list, and we'll say the remove and evicted. So that's got removed, and we want to remove this from the map. So we want to get the key, and that's what I was explaining earlier. So in evicted has the key. So evicted, this is a element, so I can just say evicted element. So let's get the data from here. So this DL remove, so I'll say data is equal to this one, and that, and type is star data, the evicted element dot value. Okay, because that's the element value, and then data. So we got the data here, and this data data has a key, so we'll delete from the map. So delete, and the map is our cache, so this dot cache and data dot key. Okay, so this function is done. For the put functionality we have implemented, let's use the get. So in a get, when you get the key, so let's copy and paste, and just will modify from here. So this is cache and key, so we got the key, and if I do not get the key, I'll just say return -1. So I'll modify this, so I'll get a key, so we got the element here, and from the element we want to get the data, so that's a dot and star data, because the element value has our data object and the type is this, so data, and then from here uh, whatever you get data dot value, we can return that. And since we already access this, so we want to move this to front, so we have element here and we move to the front. So that's good. So let's run, check for any syntax error or any issue. So I need a comma here. Let's run again. Data evicted element value. So this is the value, and you got, and then we are converting this to data. So what's the issue here? Still, let's run again. What is there? Cannot call non-function evicted element value. Oh, value is the function. element that, no, I think this is good value, and type is start data, evicted element value dot, oh, dot was missing. Okay, accepted, running. Yeah, so we can see the full code here, and then also we'll see the Java solution. I have used exactly the same logic over there, but the different library in a Java. So till here constructor, and this is the get functionality, and this is the put functionality. Okay, so that's all the code. Let's see the Java solution also. Exactly same thing in LRU Cache, same variable. It's a LRU Cache constructor. It's a get functionality. This is the put functionality. And you can see here I've used the linked list here, and there's a put functionality here. So that's all for now. Thank you.